Hi everyone, today we're going to learn about the ambiguous case, which is a special case of law of sine. But before that, let's go over what we have learned about law of cosine and law of sine. We know that if we have a triangle that has all the sides given like A, B, and C, this is a case that we call that side, side, side. In this case, we use law of cosine to solve for any missing side or any missing angle. The other case that we use law of cosine is when we have two sides given and the angle between them, something like this. We call this side angle side, and notice that the angle is between the two given sides. Again, in this case, we use law of cosine to solve the triangle. Law of sine can be used when we have two angles given, like for example A and B, and the side between them. We call this angle side angle. And you see the side is in between two angles. So in this case, we use law of sine. The other case of law of sine is when in your triangle you have one angle given, the second angle given, and then we have one side given, which this side is not in between two given angles, it's just outside of them. So we call this angle side. There's also another case, which in this case all the angles are given. So you say angle, 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 and in this case we are not able to solve this for any sides. So this is not possible to solve. The other case that we have is when we have a triangle that two sides are given. For example, A, B, and an angle is given. So we have side, side, and angle. So in this case, we use law of sine, but this is called an ambiguous case. Why? Because we're going to have two answers in this case. Sometimes both of the answers are acceptable, sometimes only one is acceptable, and sometimes we don't have any answer. There's no solution. That's why we call that ambiguous case. So we're going to talk about this ambiguous case today. So let's start with this example. In this example, we have a triangle like X, Y, and Z. Angle X is given, it's equal to 27. Side Y is given, it's 5. And side X is given, and it's 4. As you see, we have two sides given and one angle, which is outside of these two sides. It's not in between them. So this is actually an side-side angle case. So in this case, we use law of sine, and it's going to be an ambiguous case. So let's start solving this. To solve this for angle Y, I'm going to use law of sine. The first part of law of sine that I'm going to use is the X part, because I have both angle X and the side X. So I'm going to write sine of X over X equal to, the second part is the Y part, because I know I'm solving for angle Y, so I have to use this part of that. So sine of Y over Y. So I'm going to replace whatever I have here. Sine of 27 over 4 is equal to sine of Y over the side Y is equal to 5 over 5. Now in order to solve this, I need to cross multiply. So as I cross multiply, I'm going to have 4 sine of Y equal to 5 sine of 27. Then I divide both sides by 4. Notice that I'm dividing by 4, not by 4 sine, because at this point this sine and Y are basically stuck together. This is just function sine of y, so I can separate them at this point. So I just divide by 4, and then I will have sine of y equal to 5 sine of 27 over 4. And then if I use my calculator, I will say that this is equal to 0.567. So just enter this to your calculator and make sure your calculator is in degrees mode, and then you're going to get this answer. Now we need to solve for angle y. To solve for angle y, I need to take the inverse function of this value to find angle y. If you remember, we said to find a y which is stuck in a function of sine, you need to take the inverse of both sides, like sine -1 of both sides. So these two cancel each other, and then we're going to have y equal to sine -1 of 0.567, which that will be equal to, you see, sine -1 of 0.567 is 34 point something. I'm just going to round it at 35 to make our life a little bit easier here. So the angle y is equal to 35. But here's the deal. We don't have only one answer. We basically have two answers. One is y1 and y2 is the second answer for this angle. How do I find the other one? Let's have a quick look at unit circle. On the unit circle, angle 35 is going to be somewhere around here. And we know that this point has coordinates of x and y. We know that the y value is sine. If you remember, we said x is cosine and y is sine. So this y, which is equal to sine, is basically this vertical line. This is the value of y, or sine of 35. Now, I know that there is a reflection of this angle on the other side of this y-axis. So this is a reflection of this angle over here. This angle also has the same y value because it's just a reflection of this one. So basically the y value, or the sine of this angle is the same as the sine of this 35. So that's why we say we have two answers, not only one. So how do I find the second one? We know that this whole thing from here to here is 180. And I know since this is a reflection of the 35, this part is also 35. So if I just subtract 180 from 135, from 35, 180 minus 35 is equal to 145. That's the measure of this angle from here to here, and which is the second answer. So we had two answers for y. One was 35, the other one was 180 minus 35. So this is how we find angle y. We call this ambiguous case because we have two answers. Well, in this case, both of the answers are acceptable. We'll see later that sometimes one of them is not acceptable and sometimes we don't have any answer at all. Anyway, this was the first part. Now I'm going to work on the second part. We're going to solve for z. In order to solve for side z here, I need to have angle z first. How do I find angle z? Easily, because I already have y and also have x. I can add them together and subtract from 180 because I know all the angles in a triangle add up to 180. So subtract those two from 180 and I will get angle z. And then I'm going to use law of sine again to find angle z. But since I had two answers for y, I'm going to have two answers for z as well. So I have to solve this two times. One for this y, the other time for the other y. So let's go ahead and work on that. If I consider the first case, which y1 is equal to 35 degrees, then angle z will be equal to 180 minus angle X, which was 27, minus this 35. This will be equal to 118. So angle Z will be 118. Now I'm going to solve for side Z here. Sine of X over X equal to sine of Z over Z. You could also use sine of Y over Y, both of them works, but I just used sine of X because they were just given here at the beginning. Okay, so sine of 27 over 4 equal to sine of 118, that's the Z that we just found, over Z. Now to find side Z, I just do cross multiple here. So Z will be 4 times sine of 118 divided by sine of 27, which will be equal to 7.78. So this is how I find side C here. Then I'm going to consider the second case, that y2 was equal to 145. Because we had two answers for y, I have two answers for z, and I have to do both of them. Okay, so here angle Z will be equal to 180 minus 27 minus 145. Notice that this 27 that I also used it here is my X angle, which is constant here, it's not changing. Okay, so if I subtract this, I'm going to have 8 degrees for angle Z. Now I'm going to do the same thing that I did here to solve for side Z here. Sine Z over Z, and this is sine 27 over 4 equal to sine of 8 over Z. And then do cross multiple, and angle Z will be equal to 4 times sine of 8 divided by sine of 27. And this will be equal to 1.2. So that's how we solve for side C here. So in this case, we had two answers for Y. Both of them were acceptable, and based on those Y's, I found the other side, which was C. Now let's work on this example. We have another triangle here, which is again X, Y, and Z. Angle X is given is 27. Side Y is given is equal to 5, and side X here is equal to 6. Now we want to solve for Z like what we did here, but like here, if I want to solve for Z, I have to find angle Y first, because to solve for this angle, for this side Z, I don't have anything for Z. I don't have Z, angle Z. So I have to find angle Y first, then subtract both of these from 180. I get Z, and from there I'm going to find side Z. So let's start. First, solve for angle Y. To solve for angle Y, again we are going to use law of sine, because we have a side angle case here. So it's going to be ambiguous case, law of sine. So I start with sine of X over X, because both angle X and side X are given, equal to sine of Y over Y. So here I'm going to have sine of 27 over 6, which is side X, sine of Y over side Y, which is 5. Then cross multiple. As you cross multiple, you're going to have 6 sine of Y equal to 5 sine of 27. Then we divide both sides by 6. And from here, sine of y will be equal to 5 sine of 27 over 6. And if I use my calculator, I will see that this part is equal to 0.37. So sine of y equal to 0.37. Now I need to solve for angle y. I need to separate this from this sign, undo the sign. How do I undo function sign? Using inverse function. So I can say angle y is equal to inverse of 0.37. And that's equal to inverse of 0.37 is equal to 22 point something. So I just rounded to 22. It's equal to 22 degrees. But if you remember, we said in this case, because it's ambiguous case, we're gonna have two answers. One of them is this 22. The other one, like what we did here, you just need to subtract this 22 from 180. So 22 subtracted from 180 is equal to 158. Then I need to solve for z. Like what we did here, we need to find angle z first, and then from there we're going to solve for side z. So to find angle z, I need to add the other two angles, x and the found y, and subtract that from 180. So here angle z will be equal to 180 minus 27, which is our x, minus 22, which is our just found y. Well, this will be equal to 180 minus 49. That's equal to 131 degrees. And for this one, angle z will be equal to 180 minus 27, which is the x, and minus 158, our new y. So if you find this, you're going to say that this is equal to -5. And there's no way that we have an angle in our triangle that the measure of that angle is equal to -5. This is not possible. So we say this is not acceptable. 131 is the only answer that we can accept. So we're going to take this angle z and use that to find side z. So sine x over x is equal to sine z over z. Sine 27 over 6 is equal to sine of 131 over z. Then you cross multiple, and from here z will be equal to 6 times sine of 131, 6 times sine of 131 over sine of 27. And this is equal to 9.9. So that's how we find side z from this law of sine. Okay, now let's work on the last problem. Okay, here again we have another triangle, x, y, and z. Angle x is given 27, side y is 5, and side x is 2. As we see again, we have side angle. So because this is side angle, we have an ambiguous case. We use law of sine to solve for missing side. So I want to solve for angle for side z, but because I don't have angle z, I'm going to find angle y first, and then use that to find angle z and side z. So let's start again. Um, Sine of x over x. Once again, I use sine of x over x because I have both of the angle x and side x. And then sine y over y. So this will be sine 27 over 2 equal to sine of y over 5. Then you cross multiple, we will have 2 times sine of y equal to 5 times sine of 27. Then we divide both sides by 2, and sine of y will be equal to 5 sine of 27 over 2. And if you use your calculator, you will see that this will be sine of y equal to 1.13. If I use my calculator to find y should be sine -1 of 1.13. And let's see what happens if I find sine -1 of 1.13. Second sine of 1.13. As you see, we're going to get a domain error. Why does this happen? Because we know that the maximum value that a sine function can take is 1, not anything bigger than 1. When this number is bigger than 1 is 1.13, which is not possible. So here I can say there is no solution. We can't solve this because the sine value cannot be any number bigger than 1. So this was about ambiguous case. Once again, let's go over what we did here. If we have a case of side-side angle, we have the ambiguous case. We are going to have two answers. Sometimes both of the answers are acceptable, like this case. Sometimes only one of them are acceptable, like this one, and sometimes we don't have any solution at all. So this was today's lesson. I hope it was helpful for you all. Have a good day.